guess I want to do it. Okay. So we are recording, and I want to welcome everybody to GLREA's Solar Stories on October 1st, 2020. Our special guest this evening is Wayne Appleyard, who is a longtime member and supporter of the Great Lakes Renewable Energy Association. Wayne's going to make a presentation about his home, and it should be a very interesting presentation. Wayne has been very active in renewable energy for many years. He is an architect and I guess maybe a solar contractor of sorts. So we're going to have Wayne make a presentation, and then we'll take questions and answers, questions from from those folks that have joined us this evening. So without any further introductions, I'm going to turn it over to Wayne.
Thank you, John. Yeah, I've been an architect since 1983. Sun Structures Architects was started in '74 with a group of my friends, and we've been doing passive solar architecture and green buildings since long before it was called that. Right now it's down to me, and I've moved my office home to my house, which this is my house, which my wife and I bought in early 90s. And it was not the optimal solar house because it had absolutely no solar exposure. The south end of the building is the garage. It was very leaky. It had almost no insulation. It had slide-by aluminum windows that let a lot of air in, but it was a nice spot. So, and it had oil heat and no access to natural gas. So we started with that. So this is the original plan, and you can see the garage is on the south end of it. And we had 2 small bedrooms. We had 2 young children at the time, and so we really needed some more space. So I decided that the car could live outside. And so I expanded the house to the east and the west of the garage and made all that living space so I could get, a solar exposure along the south wall here with a lot of south-facing glass. I added a wood stove, insulated, added a porch out the back. So I put a lot of insulation in the attic. I put 1.5 inches of foam on the outside of the walls, and then purlins and 5/8 inch OSB, and finished it off with cedar shingles and added low-E windows, just double pane because this was the early 90s. And sealed things up as best I could, partially by extending the siding down over the basement wall a little bit beyond the wood deck, so it really sealed that off so it doesn't leak. So here's the new solar exposure with a combination of a lot of direct gain windows here, and then mass walls here and here and here. And then when I moved there, I had an old batch heater, and I put that in the roof, which we'll talk about in a minute. So this is basically what the mass walls are, or trome walls. So there's glass on the outside and airspace, a selective surface on 8 inches of solid concrete, and then it radiates heat through to the inside of the room, basically at night. So here's a close-up of one of those walls, and another section of the wall. And this is on the inside. So behind all that green concrete block, which I actually cast myself, there's glass on the outside. So it absorbs the heat, and it comes in, and it takes 6 to 8 hours for the heat to start coming into the inside from the outside. So we can have more solar gain without having overheating in the house. So the mass wall, you can see, only starts putting heat in late in the day, and then it peaks out perhaps at 85 or 90 degree surface temperature on the inside at midnight or a little later, and then it tapers off. So we doubled the space. We had about the same heating load or a little less, and had a lot more daylight and views. So it worked out pretty well. For the time, it was what we could afford and what seemed to make sense during those 90s when, you know, really severe energy efficiency was on the back burner, I think. And there's my batch heater that I built into the roof. It's still there and it still works. It's just a 40-gallon hot water heater tank with selective surface on it with several layers of glass on the top. And that basically preheats the water that goes to my regular hot water heater. Not anything I'd really recommend in this climate. You have to keep the pipes from freezing in the wintertime. And in the wintertime, it's probably a little bit of a loss, but in the summertime, you'll get 120 or 130 degree water out of it. So moving up to 2019, the tax credits were at the height. I was telling everybody that we needed to be net zero, and here I was in a house that used a lot of electricity and fuel oil. So it seemed to me that it was about time that I did something for myself. So it came down to figuring out how much PV I would need and where to put it. So this is an aerial view of the house, and this is my pole barn, which was moved from someplace else by the former owner and put it back together. And he was a mailman, not a carpenter. So it was really pretty rough. You could see all the rust on the backside. The siding was wearing out. The siding was probably almost 100 years old. And notice almost all of our roofs faced east-west. And so there wasn't a whole lot of good spots for PV. So I decided, and I had room for ground mount, but I really wanted to, being an architect, I wanted to put it on a building. So I decided that I would put it on the pole barn. But first I needed to figure out how much I needed. So I use about 600 gallons of fuel oil a year, which when you work through all the efficiency and with an air source heat pump with perhaps a coefficient of performance of 3, you end up with that many BTUs, which works out to be 5,700 or 5,800 kilowatt hours a year. So, which would be somewhere between 5 and 6 kilowatts of PV just on its own, just for the space heating. So what I decided to do was get a very high efficiency air source heat pump, because I looked at geothermal and it was going to really rip up my yard and it was going to cost a whole lot of money. So for a lot less, I put this where the oil tank was, which was kind of nice. I had this little spot for it. And it's sort of a mini split, but it's not really a mini split in some respects, because we had all this ductwork in the house. So the refrigerant lines come into this branch box that splits it up and goes to 2 air handlers. Here's one of them. And then there's one for the south side of the house. And it used all the original ductwork. And we've had that since last October. And we're amazed at how well it works, how quiet it is. And because of the lower temperature air that comes out of it, it's almost like having radiant floor heat. It's amazing how even the heat is in the house in the wintertime. And my wife has complained that several times she's gone out the door thinking it was warmer outside than it was, just because the house was so nice. So we're real pleased with that. So here's the current situation. You know, we had this house kind of built out, so to do more energy efficiency work was going to be difficult. I still have a few more things that I could do. We live in the country, so we have and no natural gas. So we have an electric dryer, we have a well pump, we had a furnace fan, and my office is here now, and we had basically a through-the-wall air conditioning unit. So that ended up being about 11,000 kilowatt hours a year, which for you folks that live in the city and have natural gas and no well pump, that probably looks high. But so then I figured, you know, I figured out 5.5 kilowatts peak for the heat pump. And then couple of thousand miles for potentially an electric car, which I didn't have at the time. So somewhere it's between 15 and 16 kilowatts. And the thing that I've come to figure out is that there's kind of a sweet spot for every project between energy efficiency and PV. And at some point in time, you just throw more PV at it. And it means that you don't have to use a tremendous amount of foam to try and reach passive house and create a house that's so tight that you're afraid you're gonna run out of air in it without an air-to-air heat exchanger. So, and since everything was kind of built out, I decided to just bite the bullet and put it on the barn. So this is the funky barn. It needed to be covered up with siding of some sort. This is the southern exposure, and you can see we have shallow pitched roofs that faced east and west. So what I decided to do was take the roof, have it completely re-roofed, and have the whole south half of the roof ripped off completely, and new trusses that had 6 and 12 pitch to face south for the principal part of my photovoltaics. Had a lot of time trying to find somebody to help me out with it. I did some of the beam work in town, but inside, but I finally found a group of Amish folks that had put some barn roofing on a barn on the way to Ann Arbor. Was able to contact them. They gave me a real good price, and they came out, and it's amazing the job they did. And it was amazing because until the end, I hardly knew the guy's last name. All the materials showed up and were put in place. I never had a contract with him. And the guy showed up a week or two later with one of those carbon bill things that you buy at the store. And he wrote Wayne on the top and wrote materials and labor and put the final price on it and handed it to me, and I handed him a check. So it worked out really well, and it was a lot cheaper than any other bid that I got. So here's the south-facing roof after we ripped it off and put the 612 pitch trusses on it, 4 feet on center. And the neat thing that I decided to do is that I'd helped John Wakeman with his garage. And John Wakeman, as many of you know, is a local solar installer. And he's come up with a system that allows you to use regular standard photovoltaic panels and make it the roof. And I've always thought that solar should be the roof. You know, they last so long, why not make them the roof? So his garage was his project number 1 of this system, and this is number 2. So this is a system. He offsets the panels by 5.5 inches, so these joints don't all line up, which makes it a lot less complicated to keep it from leaking and everything, and then you just fill it in. So one of the tricks here was figuring out, I wanted it to be the whole roof, so we had to figure out how long that number of panels with the spacing between for the bolts was to be, and we ordered the panels and they arrived on site, and I had the guys frame in the roof, and John gives me a call and goes, you know, I measured those panels today and they're 3/4 of an inch longer than what the material from the manufacturer said they were. So I got the crew to rip off the little back overhang and make it another 6 inches longer so we could get it to work. So it's one of the downsides to the system, but it's really quite nice when it all gets done. So I extended the overhang out to the front where my doors are here, so that the number of panels would work out, the dimensions, and you can see them working away up the roof. And you can see these beams that I put out to pick up the extended overhang. The other thing I did with the trusses, I put clear plastic on the trusses, which provides incredible daylight in my shop. It's just really, really wonderful. So, and this is the inside. So all of the electrical is totally accessible. And I saved the metal, you know, I didn't have to buy metal roofing and additional connectors and everything to hold it on top of the roof. So there's a little bit of savings there. And it is the roof and it doesn't leak. So they're shingled basically. It's a little hard to tell, but each row is set just on top of the edge of the row below, and they go up to the roof. So that was 9.3 kilowatts. And I put an extra 6.2 on the low slope west facing roof. And I did it partially because that's where I had more roof, but also because it gives me two different systems that I can compare over the course of the year and show people that a west facing roof can work pretty well, as you'll see towards the end. So the barn got all re-sided, re-roofed, and new panels. So, and I have 2 Solar Edge and a new 100 amp panel that feeds to the house. So it's 15.5 kilowatts of panel, but it's only 12.6 inverter because we're doing what they call clipping. So, and I don't know how many people understand clipping, but basically that real peak that you get at the top is only there for a little bit every sunny day during a certain portion of the year. And so instead of going for that, you're actually getting the panels to turn on and provide electricity over a longer period of time because the voltage comes up to what it needs to be faster, and the amperage comes up to the point that it'll turn on. I was a little bit skeptical, but they said that you could go up to 1.3 times the inverter capacity on the panels and have it still work out with the same amount of solar gain over the year. So we'll see how that's working out in a minute. So I had a 200 amp panel in the house that was maxed out with a heat pump. So I actually had to get a 300 amp service. So it meant that I had to call consumers, and they were very nice. They came out, they gave me a new transformer, a new pole, new underground, and a new meter and meter box. They dug up my yard, but made a bit of a mess. But and it took a long time to get everything squared away with them because this was a little bit of an odd duck for them. So this is a new enlarged meter box. So the 100 amp comes in from the barn and goes directly to the meter, the house side of the meter. So it doesn't go through the panel inside of my house at all. So the disconnect is next to the meter. And so I had to get a 300 amp bidirectional meter, which they came out and put in. And then of course, a month after that, in March, I decided to make use of their EV charging program. And that meant I had to go to time of day. And so they had to come out and take that meter out and put a different meter in. And this meter that was originally in here, the guy had to come out with his little handheld thing to read. This one, that reader won't work on it. So what I do is once a month, on a certain day, I go out there and I read about 5 numbers off of the meter, and I write it into an email and I send it to somebody at consumers. And they're supposed to be figuring out my bill. Now, I started in March. I still haven't gotten a bill from them. So another picture of the panels and the overhang. And there's my level 2 charger, which is hooked up to the internet so that they can keep an eye on me. And I found a very used 2011 Volt that I bought and have been using. And right now, since I bought it, it's running 230 miles per gallon on the gallon side. And I haven't looked to figure out how much electricity it's using, but as long as I don't go too far, it works really well. And that's where I put it on the barn. I still have to paint the front side of the barn yet. But so this is a look at the panels on the roof as of today. For when we started, it's pretty interesting because the best panel on the south has done about 313 kilowatt hours, and the worst one on the west is at 297. So far, there's not a whole lot difference between those two systems as far as how much they're putting out in relationship to each other per panel. So one system is half again bigger than the other one. So, and I charted out what PV watts did is the blue. That's what it predicted on the average for the south. And then the gray is the actual on the south. And then the PV watt on the west is the orange, and the yellow is the actual on the west. So, you know, it varies a little bit month to month, but it looks like it's working out pretty close. And so this is my time of day between March 20th and actually September 30th, because I went out there this morning and read it again. On peak, I've gotten 120 kilowatt hours from consumers. Off peak, 2193, and I've sold to them 4692 on peak, which they give me more money when I sell it to them on peak, and they charge me less when I buy it off of them off peak. So that's a pretty good deal. So far I'm over 5,500 kilowatt hours ahead. So that should carry me through the winter pretty well, I think. And that's just a graph of the system to show how it varied month to month. And I'm just about through here, but I wanted to show you just a couple of other things that I've done. Several years ago, I looked at heating degree days for Ann Arbor over 9 years and how it varied between the most heating degree days per month and the least heating degree days per month and the average. So you can see there's a big fluctuation from year to year. And the cooling degree days are similar. So coming up with I don't know how any of these utility companies can easily say, well, you're oversizing a system with that amount of variation. And then on the other side, the amount of solar available, and now this is solar on a horizontal surface over 15 years. It varies quite a bit. And month to month. And that's really it.
Well, that's great, Wayne. That was a very interesting presentation. So let's open it up for questions. Just everybody take yourself off mute and speak right up and ask Wayne your question or comment. That's a great picture.
Yeah,
I
Wayne,
took that yesterday, I think.
Yeah, Wayne, Clifton Brown here. Question on your roof waterproofness. The panels are overlaying each other slightly like traditional shingles. What's to keep water from creeping up as it's wind blown? Are they caulked?
No, there's actually a whole set of bent aluminum flashing that interlocks everything so that it can't sneak up through there.
Okay, so you've got a barrier with flashing that's bent and somehow interlocks from one to the other.
Yeah, it's like, yeah. And this is a patented, or at least a patent pending system.
Okay, is it something you designed or something commercial?
No, this is John Wakeman's design. So
Okay.
John Wakeman from SUR Energy out of Ann Arbor.
Okay, because I may be
I helped him
interested.
do the first one on his garage.
Okay, because I may be interested in trying that technique out where I live.
Sure. Yeah, I'm in the process of getting one done on a carport in Ann Arbor, hopefully soon. So that'll be number 3.
So Wayne, this is John Kiley.
I just couldn't pass it up. I've wanted to do solar as roof for years and years, and the barn was a good choice because, it actually leaked before we redid the roof. So if I had a leak in there, it wouldn't be a big problem. And we haven't had any leaks. Once he got it all finished, it's been just fine.
Go ahead, John.
There's no, so the barn is not heated. So this roofing system cannot have any insulation, correct?
Correct. So if you were going to put it on a house, you'd want to put the insulation on the bottom cord of the trusses so that you could still have access to the electrical.
Wayne, this is Karen Flurium. What kind of pitch is on that roof?
That's a 612 pitch. Now, I should say that this is better for, and is really designed principally for accessory buildings, because the code requires, if it's a domicile, you have to have space up each side and over the ridge so that the firemen can come up and break a hole in your roof.
I think my condo's got the same pitch. It's very shallow.
6 and 12 is steep.
Not compared to New
Well,
England.
a standard pitch is usually like 4 and 12. So this is a little steeper than that. John's first one, I think, was 8 or 10 and 12. And the carport that we're doing is 412.
You're not planning on doing any storage, I take it?
I'd say not for a few years yet. Right now I have a small gas generator that I can wheel out of the barn and run extension cords through the window and deal with it whenever it's winter time and power goes out. And I have a wood stove. So no, eventually maybe, but I've got 10 years of net metering. So, the grid is my friend and the grid is my battery.
Other questions for Wayne? John Mirsky, do you have a question?
I do. Hi, Wayne. I'm wondering,
Hi, John.
did you make any mistakes? Or what would you have done differently, even including timing? Would you have done this, had you known earlier or later, or what are your lessons learned for the rest of it?
Well, over the whole process, I'm sure I made a ton of mistakes. If I were doing the house again, I'd get more insulation in the walls. Probably try and get better windows, but it was sort of what I could afford and what was available at the time. Now windows are a lot better than that. I probably would have done this sooner if I'd known how well it was going to turn out. But we hit the peak as far as taxes, credits, net metering, and the lowest collector costs. So I think we did pretty well that way. As I mentioned, we did make a mistake on the width of this roof, and so we had to extend it out, but we caught that one in time. Oh, there's one other mistake. Let me see here just a second. I'll show it to you. It's a cute one. So
Please, for folks that are on this, put yourselves on mute if you're not asking Wayne a question.
So anyways, you know, John had to run the underground from the barn to the house and then put the disconnect up on the wall. Well, the first time he did it on the left side of the meter box. And then consumers came out and goes, we don't allow you to run conduit across our line. So originally the conduit went behind that big piece of conduit that goes up to the meter box, and the box was over there. So now my nice shingles that are flared out at the bottom, that I actually had to steam the shingles to get them to fit to that, have a nice big hole in them. But before it gets really wintertime, I'm gonna rip that apart and redo that. But other than that, you know, I think everything went pretty well. I was able to do all the big beams in the barn myself, which was a bit of a trick because there was so much stuff in the barn, but I think that worked out really well. Oh, the other thing that was pretty funny was, you know, we did all this work at once. The air source heat pump, I made sure they got a permit from the township. I did the wiring on that, a whole lot of number 6 wire all over the place. I got a permit for that. I knew I was gonna do the barn. I took my drawings into the township, gave them to them, said I'll need a permit, made sure that John Wakeman got a permit for the PV, called them up a week later and they said, nah, you don't need a permit for that barn work. So I went ahead and did it. And that was in December. In August, I got a letter from the township saying, you know, you need a permit for that work that you did on the barn. And then asked me to call the building inspector. So I called the building inspector, and he's one of these guys, he's a building inspector for probably a half a dozen townships out here. And he said, I explained the whole thing and how I'd gone in there and gave him drawings and asked for a permit, and they said they didn't need one. He goes, well, if they told you you didn't need one, I'll work it out. I'll call them and say you don't need one. So I never had to get one. Try that in Ann Arbor.
Other questions for Wayne?
This place is really kind of interesting. When I did the electrical on the addition of the house, I called for an inspection and I gave him my office number and I never got a reply. So I went to work and my wife calls me. She goes, Wayne, there's a car in the driveway and there's someone sleeping in it. And I thought for a minute and I'll go, you know, I bet you that's the electrical inspector. He might have some other place to go. You better go out and wake him up. So he came in and with the phone and we walked around and he told me if I needed to change anything. But so anyways, other questions?
Hi, Wayne, this is Bob Stink. I did the same thing with Consumers Energy, switched to the time of day pricing, and it does take them several months to straighten it out. One day I received a very thick envelope with, I think, 8 months of bills in it that were corrected bills. So eventually they get it straightened around.
Well, that's good. I haven't gotten a single piece of paper since March from them, so.
Hi, Wayne, this is Dale and Janine. Enjoying your presentation. How's the mini split working out when it gets really cold in the winter? Is there a certain point where you have to switch over to electrical supplemental heat?
It's a good question. I do have in each of the air handlers supplemental resistance heating, but because of the limits of my panel and how much each of those things had a a 50 amp break, 240 breaker on it, that I had the contractor set it up so if the heat pump can't keep up, it switches over to the resistance. And I'm not sure if it ever did, because during the winter, I didn't get any monitoring equipment on it. In early March, I think I put a kilowatt hour meter on the heat pump itself on that circuit, and I've got to do it on the 2 air handlers because I want to know if those things ever come on. I don't think they did. Of course, we had a fairly mild winter. But no, it's been just fine, and I'm just amazed at the difference. Of course, we had a 30-year-old oil burner that was probably 50s technology, and you knew it when that came on. But it tried to burn the house down twice last year. So I decided, because the controls started going on it, and so I decided it was really time to go.
Wayne, this is Lee Andre. And
Yeah,
I'll tell you an experience that I had with resistance heating and ductwork, like you were just talking about. Somebody had used a setback thermostat, and the concept of can the heat pump keep up was a function of whether it was running and the temperature in the house was more than 3 degrees off set point. So every morning that satisfied the criteria that the heat pump couldn't keep up because it was 5 degrees off set point. And so the resistance heaters came on every morning just because they manipulated the set point, not because the heat pump couldn't keep up. So be careful with changing the set point.
That's a good point.
Clifton
That's the
Brown
one
here
thing that I
again.
haven't done is I really need to go back and, go ahead.
Yeah, question on your heat pump. I think it was a Mitsubishi from the logo. So it works down happily below freezing and has still got a positive COP? Most of them you'll give up for kind of around freezing.
They have improved these rather dramatically. It'll work down to, I think, between 13 and 20 below zero.
Whoa.
Without, producing something. Without, you may need additional resistance heating to that. And the COP tapers off as the difference between outdoor temperature and indoor temperature.
Right, but it's still above.
Obviously. But
it's still above unity?
Oh, yeah.
Okay.
Yeah.
The reason I ask is I've got a heat pump with propane backup. And it typically gives up and switches over around freezing. And it's a newer heat pump that's supposed to be pretty good. We just bought the house 6 months ago and it came with a house. So I'm investigating the intricacies of that.
That Mitsubishi unit is very good. The Mitsubishi unit is very good. I've seen coefficient of performance of 2 when operating at minus 13 degrees.
Jeez. Oh my gosh.
And
Are they appreciably more expensive per BTU kind of thing?
Go on the internet. There's actually a study out there that will describe this for this low temperature performance. It was a test done in Minnesota a couple of years recently.
I took bin data for Detroit, which is the number of hours of the year that we were at any given temperature, and converted that and used that with COP figures that I got from either Mitsubishi or LG, I forget which one it was, and came up for the year in Ann Arbor, because nobody seems to have done this, that you'd get with that particular unit a coefficient of performance average of 2.7.
Nice.
So it's obviously a lot higher than that in the spring and the fall, and somewhat lower than that in the dead of winter.
Other questions for Wayne from other people on Zoom?
I have a question.
Go ahead, Bill.
Can you tell me more about the time of day pricing? I've got 3 solar arrays here on the roof of my house, and I'm down in Columbus, so it's American Electric Power, and I'm tied to the grid, but I'm not familiar with the time of day pricing that you mentioned.
Not everybody provides that. Consumers basically is doing it principally, I think, on a residential level for people with EV chargers, and it's part of they gave me a $500 check for me putting in a level 2 EV charger for my Volt, under the condition that it was one that they could interface with. So they're gathering data on when I charge my car and when I use energy in both on peak and off peak. The hour changes are between 11 o'clock in the morning and 7 o'clock at night is peak, and the rest of the day is off peak. And at least during the summer, just the energy component, they were paying me, or I was paying them, depending upon which way it was going, 12 cents during the peak time and 8 cents during the off peak time. Obviously, there's other charges that go in there, but that's what they modify. That doesn't include distribution or transmission or anything else.
Thank you.
This is Clifton again. This may have changed, but I've got an electric car and was dealing with consumers rather painfully about getting it, hooked in and that kind of thing. And, found out that we had to go to their time of day rate, which I forget the tariff number. I think it's like 1020, like your tax return or something like that. And he let slip that everybody was going to be forced to change to it January 1. So that if I changed early so I could get the electric car discount on the charger, I had to change to it then. So I've eventually got all of the rate numbers and ran my spreadsheet against it. And for my usage pattern, as long as I can load shift a little bit, was a break even. So that's sort of turned out to be. But I guess just a heads up to people, looks like that's going to be coming for everybody, not just EV users. Because he let that slip. Now, whether they can actually make it happen is a different story, because they're trying to load shift. And the hours that I have, maybe I misheard, I think my hours are 2 p.m. to 7 p.m., not 11 to 2, not 11 to 7. So we both probably want to go back and double check that, because it makes a big difference on how I load shift.
This is Bob in Grand Rapids again.
Okay, I actually have it open here, and it's between 11 and 7, and it's called the RT 1010 rate, residential time of day, and in the winter months, off peak is 9 cents and on peak is 10.3, and in the summer it's 8.5 and 12.3. At least according to what they sent me, and I'm not sure if that's current or not. No pun intended.
Yeah. Well, I'll have to double check then. I could be wrong, but I've seen this both in documentation from consumers and on my bill. I had no trouble getting active paper bills from them. Yeah, okay, well, I'll believe you.
Okay, let's go back to Bob. Bob Sink's got a question.
Thank you. So I have electric cars also, and I went with the electric car rate, which is different from the residential time of day rate. The electric car rate was more complicated. They had a peak, a mid peak, and an off peak. So they had 3 different pay scales, and for a while I had 2 meters, 1 meter for the house and 1 meter for the cars. And then when I got solar panels, and then they said I couldn't have the car rate anymore.
But actually you can. Somebody in Ann Arbor's got modules and a car. They had to do it, so he grandfathers everybody now.
But that might be DTE though in Ann Arbor. That might not be consumer.
That's DTE.
No, that's
I'm on
consumers.
and I have both a car and not in Ann Arbor.
Well, but this person, I believe,
is Detroit Edison.
Yeah. Okay, maybe I'm wrong there. But the bottom line is consumers had all of these bizarrely crazy rates, and they're forcing them to simplify and get rid of a lot of the more complicated ones, boiling it down to a limited number. So again, just heads up, things may change in January, at least for consumers.
Other questions for Wayne? Any other questions for Wayne? Well, Wayne, you want to make any final comments before we wrap up?
I guess I would just go back and say a few things about the sweet point on stuff. You know, I think it's important to look at every project and figure out how far you want to take energy efficiency and how much you want to use photovoltaics. You know, at one end of the spectrum, you're building a code house that uses as much electricity as is allowed by law, and you have to put a really big array on that to be net zero. At the other end of the spectrum, you've got what they call a passive house, which has got usually has a whole lot of foam insulation and really expensive windows and everything, and you can get away with a very small array with that and become net zero. And somewhere's in between those two lines cross, and that's, you know, there's obviously other things that come into play, like how much room you have for solar panels, but that really should be taken into effect. And the other thing that I didn't say is that if it turns out that I didn't quite make net zero, I still haven't insulated my basement walls yet. There's too much stuff in the basement and it'll look like a terrible project. So I put that one off, but for instance, if I discovered that those resistance heaters are coming on and I'm not net zero, we'll start moving stuff and put insulation on the inside of those basement walls. And well, thank you all for coming and listening. It's been fun.
Thank you. I'm going to, 1 second.